Hello and welcome to the Pro Yakyu Report. I'm Michael Westby, your host. This is Season 1, Episode 12, Velocity Tracking, Part 4. Alrighty, a good place to start off this week would be to check in where we left off last week. So let's go to the shell, and let's copy last week's project to this week's. Change directory into this week's project, and start up our simple HTTP server. Run it in the background, and with that up and running, we can go to our document, and there we have our velocity tracker. If we click on switch, we can see the velocities change per inning. And when we hit change up, the 10th inning stopped changing. Curveball cutter saw the 9th inning drop out of changes, and sinker saw absolutely no change happen, and we're back to fastball or straight. Now, as a longtime jQuery user, my first thought to get rid of these non-changing innings was to grab the DOM objects that were not being updated and hide them somehow. But that's not the way the D3 library works. Remember, this is data-driven documents, so an absence of data does not help you. What one really wants to do is to pad the missing data with zeros. Now, this is a very common practice with many data analysis tools in Python, R, and other languages. So, let's open up the Velocity Tracker HTML file in our text editor and see what we can do about this. The first thing we need to add is a variable for keeping track of the minimum inning and the maximum inning. So right after the min and max velocities are saved, let's add min and max inning. Next, like we set min and max through our data retrieval loop, let's set min and max inning as well. Of course, here we're using I for the inning index number rather than the velocity. So in reality, this should give us inning numbers 1 through 10, or 0 through 9, actually. Because remember, we're doing indexes which are 0-based. And this will also handle other pitchers, for example, relief pitchers, who maybe always start in the 8th inning. You can see their range come up as well. Always good to generalize. Finally, after all of our post-fetching initialization, let's loop through all the data to make sure that each inning is covered for each type of pitch. This looks very much like our loop where we initialize the velocity, where we're setting data, sub-pitch type, sub-inning index equal to an array, and let's just set this to min for right now. Save that, and reload our page. Okay, straight, we're all there. Shoot, we're all there. Slider, we're all there. Forkballs. And when we get to change up, the 10th inning drops to 64 miles per hour. Curveballs, cutter. We see the 9th inning drop to 64 miles per hour. And we go to sinker, and everything but the sixth inning drops to 64 miles per hour. Now, of course, the minimum pitch was 64 miles per hour in this dataset's case, but we really don't want to display the minimum because this was really 0. So this was more as a demonstration of what's going on than what we were really wanting to do. So let's change the padding to zeros, save that, reload, and if we flip through the types, when we get to change up, whoa! It dropped out of existence. Curveball and cutter, hey, that dropped out of there. Sinkers, whoa! Everything dropped out except for the sixth inning. Wow. That was kind of dramatic. I like this animation. It's kind of fun. So now, looking at the sixth inning, Ma-kun threw a pitch at 83 miles per hour, or it might have been 2 pitches, both at 83 miles per hour, or it might have been 12 pitches, all at 83 miles per hour. There's no way of knowing what's going on here. So, what can we do to show how many pitches there were in a given inning? It turns out that the D3 library, which is made for creating data graphs, has some functionality that's very handy. One of those functionalities is what's called adding a tick. Okay? The ticks usually go on the X and Y axis, but we're not really using an X and Y axis in this case. But what we do have is each inning being displayed, and it would be nice to have something kind of right here on the left-hand side, written at a 90-degree twist, which says how many pitches were thrown for that inning. Now, this kind of functionality is going to have to be done in the box.js file, because this is where the drawing occurs for all of our graphs. So let's bring the box JavaScript into our text editor, and let's add a count tick output. If we scroll down here to line 203, you see we have the box tick. Now the box tick is what's drawing the ticks on the outside of each box. So we want to kind of base what we're doing on the box tick. Here's where the box tick gets initialized. So let's say update box data counter tick. This is a new feature that we're adding to box.js. And we want to pass the data. It expects an array because the array is the data that we're adding to the axis, basically. And we're going to pass it the value in. Where did in come from, you ask? Well, if we scroll up to the beginning of box.js, which I know I didn't really go over before, but right here, each group object has data associated with it. So when creating a box, we go through each created G tag with the data that's being passed, and the data being passed in this case will be straight, shoot, slider, etc. So it is an array of velocities that's being passed. What this is doing is this is creating a map of the velocities and it is sorting them in ascending order, then the n is being assigned the total length of the data. Min is being assigned the lowest velocity. Max is being assigned the maximum velocity. And if you want to go through this all, please do so on your own time. But basically what it's doing is it's creating the inner box with all of the quartile data being calculated. It's creating the whiskers for sprouting out to the minimum and maximum values. And then it's gathering up all of those outliers that are outside of the standard distribution. It's a lot of fun mathematics, but I'd rather not go into that right now. Instead, let's get back to our tick box. So we have an array which is the number of pitches only being sent to this tick mark. Next, what we want to do is cover the enter code or initialization code for when data is being assigned to an element. We are adding a text object, assigning the class countTick. This is all covered up here. Next, I am going to give it a transform to rotate the text tag 90 degrees to the left. And we don't really know the location of where we really want this yet. So let's give it an X location of 0 and a Y location of 0. But I do know that I want the text to be anchored at the end of the box that is being output for text. Now that initializes our text area, so we need to output the text area on each update, including the first one. Okay, format here is a variable that is set on line 181, compute the tick format. The purpose of having a format is to be able to control how the ticks look from the program that you're writing. The program, of course, being in velocitytracker.html. Now, I'm going to just leave this for now and come back to it a little bit later. For the time being, though, let's see what happens. Save it, reload, and hey, we've got some additional numbers here. But these aren't quite where I want them to be. So let's play around with this a little bit. Open up the web inspector. Then let's grab a hold of one of these numbers here. And as you can see, it is a text tag with class countTick, rotated 90 degrees to the left. X is 0, Y is 0, anchor is at the end, and then it's got its value. Now I want to move this left a little bit. So if I double click in there, I can say minus 30. Enter. Whoa, that's not what I expected to happen. It went down. Now, why would it go down? I expected it to go left. Let's change that back to 0 and change the Y to be minus 30. Hey, that went to the left. What's going on here? Are X and Y backwards? Well, it may seem a little odd at first, but in the ebook D3 Tips and Tricks by Malcolm McLean, he does a fairly good job of explaining this on pages 48 and 49, which are 54 and 55 in the thumbnails. Basically what's happening is that this inner box here is the text that we are looking at. Now what happens when you rotate it to the left, the origin goes from the upper left to the lower left. After all, it's been rotated 90 degrees. Now, Malcolm understands kind of how to tweak this, but in his explanation, I'm afraid that he got it wrong. What's really happening is not the x and y coordinates are flipping, it's that the perspective has changed. We rotated 90 degrees to the left, so what's really happening is this text area right here has rotated, and its perspective to its parent area is now different. The point 0, 0 is still in the upper left-hand corner in Malcolm's example on this page, but the x is now relative to the top margin here. So it would be along the negative axis going to the left. And the y is now in relation to the margin left. That is the left side of what we're normally considering the screen. So x is coming in from the right, and y is coming in from the top, according to the text tag's perspective, but the right is the top of our screen, and the top is really the left part of our screen. You really need to translate all of these into the coordinate systems being viewed from the tag itself. And yes, boys and girls, this is why it's very good to study and understand geometry and coordinate systems. Stay in school, learn math. So now that we know what's going on, if we look at the G tag that this is a child of, you'll notice that the 264 is right up against the left-hand side of the group area. And it's also a bit ways down from the top. The reason that it's down from the top is because that's where we had put our margin in earlier. So the box itself is a little bit lower than the text margin that we had put in from our main program. Nonetheless, now let's go back to our application, and for the y value, let's set that to minus 30. Save that, reload, and we've got all these numbers along the top. Hold on, didn't you say that the origin of the text was the upper left-hand corner? Yes, I did, and that was really for Malcolm's example. In my example, I have the end being the text anchor. What that essentially does is that moves the x origin from being on the left-hand side of our text to the right-hand side of the text. So, because x is 0, it is right there at the very top. So, now we can see pitch counts. But having those numbers hanging there without an explanation is kind of confusing. I wanted to say 624 pitches in the first inning, 452 pitches in the second inning, etc. So, to that end, we're going to have to add a formatter for our counter tick. So let's go back to our editor and back to the top of box.js. Just like we have a tick format, let's have a count tick format. And where is tick format being initialized? That would be right there at line 182, or I guess that's where it's being used. So let's say var counter format equal count tick format or x1 tick format 8. Now, what this does is this initializes the local variable counter format to be the object's count tick format, or if that doesn't exist, it uses x1.tick format sub 8, which turns out to be a pre-initialized function for describing general purpose formats. Basically what it does is it outputs the value that is passed to the formatter. Now to use the formatter, we want to go down to line 219 where we say format. Let's change that to counter format. And we still have not initialized count tick format. So let's go down to where box tick format is initialized and initialize box dot counter tick format. Okay, what does this do? This takes a variable x. For formats, the variable x must be a function that takes the data and the array index and outputs the values. So if no arguments are passed to counter tick format, it just returns counter tick format. That's the getter function in the object-oriented code that this is. If there are arguments, then counter tick format is set to equal the passed function in this case, and then in order to maintain the chain of command functionality that all D3 objects do, the box itself is returned. That's why we can chain a whole bunch of dot attributes to these various objects. Now let's save that and go back to our HTML file. Now this is being initialized here with chart. See where chart equals d3.box? This is our box. So after height is initialized, let's initialize the count tick format as the function of the data with index, return the data plus the string space pitches. Now let's save that and reload. And I left something off somewhere. There it is. Count tick format, not counter tick format. It does help if you type your variable names consistently. And there it's count tick format, naturally. Okay, save that, reload, and there we have it. 624 pitches, 452 pitches, 440 pitches, etc. Now, if we switch, all those values change along with the data. Switch, Okay, we've got sliders, forkballs, and the 10th inning disappeared, although that still says it's got one pitch. 9th inning disappeared, but it still has a pitch. And once we get to sinker, look at all that. One pitch in every inning, except the sinker only had one data point overall. It looks like we still have a problem. Remember we added a 0 to each data set for each pitch type? That's what's coming back to bite us here. So what we really need to do is go back to box.js, and where we're passing our value in, what we really want to do is check to see if the maximum value for this data set is 0, then we want to say that there were no pitches. Otherwise, there were in pitches. So let's save that, reload, and there, shoot, slider, forkball, and changeup has no pitches in the 10th inning. Curveball, cutter, no pitches in the 9th inning. And the money shot, no pitches in every inning except the 6th for a sinker. So he threw one pitch, 83 miles per hour, which was a sinker, over the past 4 years. Now this is much more useful when we evaluate the kinds of pitches he throws. He's definitely throwing a lot of fastballs. Shoot pitch, about a, fourth or so of that. Sliders, he's got a good number of sliders going. Forkballs, again, it's cut down a little bit, but still good quantity. It's when we get to this changeup. Interestingly enough, he increases that over the course of the middle innings, well, 2nd to 6th inning, and then the number of changeups really does start dropping off after the 6th. Curveballs, pretty consistent through 7 innings, dropping off toward the end. And cutter, seeing this data, it makes me think that either he throws the cutter very rarely, or the person who is inputting the data doesn't know what a cutter is. And I wouldn't put it past them. And of course, the one sinker that he threw in the 6th inning of a game, sometime over the last 4 years, also looks like it might be an anomaly. Did he really throw a sinker? So, what did you think about being able to see velocities broken up by pitch in a standard distribution on a page? Was it too overwhelming? Are pitch counts something that really helps being able to see? And when you have the lesser number of pitch counts, is that really indicative of having enough data to say something about? Or is this just some weird way of looking at data? I'd really like to hear from you as to what you think about viewing data in this way. And of course, for those programmers out there, I do hope that you've learned something about the D3 project and data-driven documents. This is a very powerful way of displaying graphics which can convey a great deal of data in a very short amount of space. And the techniques that are used to do this are also valid for when you're doing data analysis with other languages, such as Python and the infamous R programming language for data analysis. So all of this can really be carried over to many more fields. And now it's time for the Pocket Calendar. Openson continue with the Samurai Japan, heading over across the Pacific for the semifinals and, hopefully, finals. The Yomiuri Giants have taken over first place, despite Shichini no Kyojin Samurai being off across the Pacific at their namesake's park in San Francisco. The spring equinox for the Northern Hemisphere occurs this coming Wednesday, March 20th. Reports of cherry blossoms blooming in Tokyo more than a week earlier than last year, which was itself a record 15 days earlier than the norm, have been springing up on television reports. Spring is finally here. And while there is no Japan Baseball Weekly podcast this coming week, you can look forward to it on March 25th, a week from Monday. And with that, I submit to you this Pro Yakyu report. Thanks for joining me. Until next time, take care.